In recent times, visitors to the Sulphur Springs Park and you, the residents of Sulphur, have raised concerns regarding the gas emissions at the park site and potential health hazards that they may present. We are also familiar with the occasional rotten egg smell that often blows through the town. And so in an effort to effectively quantify, or rather, find out if these gases are safe, a team from the University of the West Indies Seismic Research Center, in collaboration with the Sulphur Foundation and NEMO, embarked on an initiative to monitor the areas exhibiting this geothermal activity. The following, therefore, is an interview with the team from the Seismic Research Center. Yes, we do have a very high-level company of persons with us this morning. As she indicated, we have with us Dr. Patricia Joseph, who is a volcanologist at the University of the West Indies Center, the Seismic Research Center. And with her is Dr. Denise Beckles. She's a lecturer at the University of the West Indies, the Department of Chemistry. And we'll also be joined with Dr. Thomas Christopher, who's on his way, I was told. He is a volcanologist at the Montserrat Volcano Observatory, and he'll be popping in this morning. We're going to have a very lively discussion, very in-depth discussion, and as indicated, wonderful. We have Dr. Christopher who's stepping in, and he's just popping in, so wonderful. So we have the whole team here this morning. Guys, welcome to the program. It is a pleasure to have you on this morning.
Thank you.
Thank you. Great. Let me begin with you, Dr. Patricia Joseph. I believe you are the principal investigator of the project, the Volcanic Gas Emissions Monitoring Project. Are you able to give us a general overview of the project in terms of what the project was for, the methodology of testings, and probably we can look at the findings as a summary?
Yeah, so in general, as was mentioned by our host, the Seismic Research Center monitors volcanic and earthquake activity in the English-speaking volcanic islands of the Lesser Antilles. One of those islands is St. Lucia. So we come here to do our normal volcano monitoring. Part of that was my responsibility in terms of the collection of gas and waters at Sulphur Springs, but towards looking at volcanic activity. In doing so, we also interacted with the staff and the management at Sulphur Foundation, and were aware of their concerns about the volcanic emissions and health. While this isn't our direct responsibility, my interest was piqued, and through funding from the University of the West Indies Research and Development Impact Fund, I was able to get money to look into what we call it quantification, but really it's the measurement of the sulfur dioxide in the air at Sulphur Springs and surrounding, in Sulphur. And we also did a comparison in Castries, just to see what the levels were, and when we were able to measure what was there, then to give some sort of relation as to what potentially might be harmful or not to residents, visitors, and the staff.
Right. Could you elaborate on the testing methodology in terms of what was tested?
Yes. So, as you know, monitoring equipment is expensive, and we were able to, but at the same time, it's a scientific study, and we wanted, some sort of a method that's standard and used elsewhere in other parts of the world. Right. So what we were able to do is use both techniques, a commercially available, what we call a sulfur dioxide diffusion tubes, as well as through Dr. Beckles' assistance and collaboration with the chemistry department at the University of the West Indies, her efforts in developing a low-cost sampler for SO2, we were able to use both techniques to investigate the emissions, sulfur dioxide emissions at the park, to compare the two methods and to see how feasible it would be to have the ongoing monitoring from the low-cost sampler as an option for further test, monitoring.
You mentioned you had multiple sites were tested.
Correct.
Was it specific? Could you just indicate where those sites were?
Yes. We sampled 8 sites in Sulphur Springs.
Right.
There's sites that would be immediately in the around the main venting area where most visitors would have to pass through. Some of the recreational pools, as well as the interpretation center, the turning point site, and the main entrance site. That was the area in and around the park itself.
Right.
In Sulphur, we had a setup at the Sulphur Comprehensive Secondary School.
That's right.
And in Castries, we had another setup there at the Sir Arthur Lewis Community College.
Okay, that's in Castries.
Yeah, in Castries.
Okay. I don't think this is premature, because I think the burning question on everybody's mind really is it safe? Are the gases safe? Are the emissions safe? Are we in a hazard-prone situation, or basically are we okay to live in Sulphur? Because I think that is the general concern. I think from visitors and Sulphur residents alike, that was the general concern and general burning question. So the question is, based on your findings, could you summarize what you found?
Okay, first of all, I have to say that volcanic emissions are harmful, depending on the concentrations. And this is something that you'll see everywhere in all parts of the world where volcanoes are present.
Mm-hmm.
In terms of the activity, it's related to activity at the system itself. If it's a volcano that's erupting,
right,
then of course the quantities of emissions would be 100-fold higher.
Mm-hmm.
What you get from what we see at Sulphur Springs, which is just passive emissions, because it's not a volcano that's active. It's when I say active, I mean erupting. It's just passive emissions from a normal active geothermal system.
Yes.
But the system itself is, for lack of other word, it's alive. It's dynamic. It's fluid, circulating and changing, finding pathways to escape, etc. So there would be times when the emissions itself is at lower levels, and then there are times when it will give a hiccup, and you might see a burst.
Yes.
So that being said, as I mentioned before, there were 2 types of monitoring: the diffusion tubes, which were set out on and left in the field for periods of up to 4 weeks. So that measured monthly averages. It's an average, versus the low-cost sampler, which took snapshot. I'm just using normal terms.
Basis, right?
Yeah, shorter time periods, 2-hour periods on a weekly basis for about 8 or 9 months.
Okay.
So we have 2 different types of comparisons, so to speak. And what we did find with the diffusion tubes, these are the ones that give a monthly average,
Right.
was that we saw clear rainy season, dry season variations in the atmospheric levels of sulfur dioxide at the park, in and around the park.
Atmosphere being the air.
Yes, what's in the air.
Right.
Mm-hmm. And in the dry season, and we were able to differentiate dry and rainy, etc., because we had access to the weather data from the St. Lucia Met Services.
Excellent.
Mm-hmm. So we were able to combine all of that to look at rainfall, wind patterns, and temperatures and so on.
Right.
And what we found for, as I was saying, the diffusion tubes, this is the monthly averages, is that during the rainy season, I'll start with the dry season. During the dry season, we saw higher atmospheric levels of sulfur dioxide as compared to the rainy season, when the sites immediately close to the venting area were lower in general. The sites that were further away from the main venting area, such as the turning point site, the interpretation center, and the main entrance site, these did not show as much variation with respect to rainy and dry. So they weren't as heavily influenced as those sites that were immediately, in the main venting area.
I see.
And that was for the diffusion tubes.
Right.
While for the low-cost monitor, and Dr. Beckles, correct me if I'm wrong, you want to explain the low-cost parts of them? I think that might be a good. Mm-hmm.
Okay. All right, Patricia, thanks. The low-cost monitor really was a way to collect samples similar to what you would spend a lot of money doing otherwise, but would be available to be manufactured and analyzed locally, which is what was done for this particular project. The samplers are set out, they absorb they pump sulfur dioxide gas through a simple solution of hydrogen peroxide, and that collects the sulfur dioxide gas, which can then be analyzed, which was analyzed by colleagues at the Sulphur Comprehensive Secondary School, and the data forwarded to us in Trinidad for analysis. The results of that showed that there was not so much of a variation seen in the wet and dry as with the diffusion tubes. But then again, because the samples were only set out for 2 hours at a time, there's possibilities that you might miss events that would have been picked up in the samplers that were set out for the whole month. The other thing, but we did notice, is that the low-cost samplers, whereas we would not use the numbers that we got from those samplers directly, but they correlated very well with the commercial samplers, so that the data, if it was the commercial samplers measured high levels, the low-cost samplers also measured high levels, so we could use it as an indicator. And then if necessary, okay, well, it's high today or it's high this week, then you could request a specific monitoring event happen, rather than to say you have to have an expensive monitoring station on all the time. Of course, that's always the best if it's possible, but this allows for some flexibility, and also having monitoring in areas where it might not be feasible to have a monitoring station.
We're talking about the SO2 gas, sulfur dioxide. Could you kind of elaborate what are the hazards from that gas in high concentrations? I know we talked about the hazardous gas, and you did indicate that there is some level of hazard. But again, let's go back to the burning question. I know in our briefing yesterday we talked about the sensitive people's groups, and in terms of persons who may be more prevalent to being susceptible to exposure to the gas. So first, could I get an indication of what the SO2 gas really is, the sulfur dioxide gas? And there we could probably look at the sensitivity of persons who may be, in terms of being exposed to high quantities of that gas, what it may cause. Yes.
Okay. Sulfur dioxide is a combustion product of sulfur. So if any reaction that involves sulfur and the presence of oxygen, you will get sulfur dioxide. It's similar to the way you get carbon dioxide when you burn wood or any other fossil fuel. The sulfur dioxide itself is an acidic gas, which means that when it dissolves in water, it forms acidic solutions. That is primarily the mechanism by which it causes irritation in humans and activity in the environment. So, for example, acid rain can be caused by the presence of sulfur dioxide gas dissolving in rainwater and then falling to the earth. The acid rain is not acid enough to burn anyone, but over the long term and in plants, organisms, materials that are not moving, then that can cause a problem. In terms of human health aspects, the inhalation of the sulfur dioxide in contact with the moist membranes of your eyes, your nose, your lungs, can form the sulfuric acid, which acts as an irritant. So people who are particularly susceptible would be the very young, the very old, persons who have compromised respiratory systems, so persons with asthma or bronchitis, emphysema, and some persons with cardiopulmonary problems. So those would be the sort of sensitive groups. And so the action is, as I said, primarily due to its acidity.
Okay, so let's bring it home then. So in terms of our findings and the spikes that you indicated across the dry season and rainy season, we are saying that there are, if we can deduce that there are times when persons who are in that group may be more susceptible to the higher levels of gases emission of SO2 than others. Is that basically a fair statement to make?
Yes, it is.
Okay,
but more so for the dry season, where atmospheric levels in the park of sulfur dioxide were seen to be above the WHO 10-minute air quality guideline. In the rainy season, this did not, we did not see the average values over this level, but as Dr. Beckers indicated, with the low-cost monitor, we were able to capture that the short-term fluctuations that are not captured by the diffusion tube, we're able to see those fluctuations where occasionally, as due to activity, natural activity at the park of the geothermal systems, occasionally you could see a spiking for very short periods of time.
Right.
So in general, while the average concentrations in the rainy season showed that it was below the WHO air quality guideline for the parks, especially the sites closest to the vents, you may have occasional spiking, which is why, in general, we would recommend that all individuals, even healthy individuals, take necessary, precautions, but particularly so the sensitive groups that was mentioned by Dr. Becker.
Excellent. So again, in general, it is safe, but obviously using some precautions.
That's right.
We should employ that. Dr. Thomas, welcome. You stepped in a little later. Thanks for joining the team. Obviously, in terms of your obvious experience in Montserrat, I'm sure you would appreciate the benefit of having this project, this pilot project here in St. Lucia, in terms of volcanic emissions monitoring and network. As a general, where do you see this being placed in terms of volcanic activity surveillance in the islands? What do you see this doing in terms of surveillance in the islands of the Caribbean?
Good morning. I think it's quite a useful project to be involved in because I think most of the eruptions in the Caribbean over the past century caught us off guard.
Yes.
And SRC is now moving towards getting good quality monitoring data for all of these so-called sleeping volcanoes,
Right.
so that we are very prepared. If there's an eruption in the future, we'll know exactly how to go about it and what needs to be done.
Excellent.
So basically what we are doing currently, what I am doing currently is you can compare it to going to the doctor for a regular checkup.
Yes.
And if you feel ill, then he'll compare the results that he's got with the results that you would have, gotten when you were healthy. So it's basically trying to establish these baselines for all these volcanoes as to what the emissions are, what sort of earthquake activity we expect from them. And if there is a change in the future, then we respond accordingly.
Excellent. Again, listeners, the lines are open. I know there may be some burning questions that you out there may have. So you can call in. The number is 459-7885. And our panelists here will gladly answer your questions. Dr. Joseph, let me ask this question. I know you indicated in terms of the specifics of your study, in terms of the analysis. Could we make any correlation to long-term health effects to your findings? Is it something where you may need partnership with other agencies, for example, the Ministry of Health or other agencies who may be able to come on board and probably use your template to work with to see whether or not there is probably, I remember somebody saying that there seemed to be a high rate of asthma in one particular location in Sulphur. Is that something that we can look into to probably have a study done?
Yes, as you rightly said, my study did not specifically address the long-term health, the effects of long-term exposure on health. And that is something that would be part of the recommendations that we would make as part of a further work. And yes, it would involve working with the local stakeholders here in in St. Lucia, NEMO, the health authorities, etc. Overall, in general, what we've seen is that there have been very limited health studies on the effects of passive emissions and long-term passive exposure to passive emissions. A lot of studies have been done on one-off events, such as the effects of volcanic eruption and the ash fall and that sort of thing, but specifically on what is going on with the population in and around a volcanic area that's just been exposed to this mild diffusive degassing. Not many studies have been done on that. So it would be something that we would encourage and with the assistance and further collaboration with the government of St. Lucia, we can try to seek funding for a study of that type.
Right. But is it something that you look to do? Okay, let me put it this way. Will there be a continuation of this monitoring? Obviously, because I did indicate, Dr. Beckles, that there were some areas of the study where some measurements were not taken. So in terms of long-term monitoring, is it something that the university want to probably go into and then look there for where we could do in terms of health studies? Is that a mandate, or is something that
It is something that we have had preliminary discussions
Right.
with NEMO, and as Dr. Beckles mentioned, the continuous monitor is something that they raised as something that they would be interested in pursuing. So having something permanently there,
Right.
and as an interim measure, we will see if there are other methods, including the low-cost monitor, that we can use while that avenue is being explored.
Right, excellent. Okay, we'll take a break now, and when we come back, we'll continue the discussions. We're discussing gas emissions at the volcanic Sulphur Springs Park in Sulphur, but we'll also be looking at seismic earthquake activity in the Caribbean. We're having some nice discussion there. Dr. Christopher is smiling. He probably knows I'm asking a few questions. So again, listeners, call in for your questions. I know you're listening this morning. We have the professionals here. It's time to ask the questions. I know there's a lot of burning questions out there. 459-7885 is the number. So we are going for a break. When we come back, we'll continue the discussion. And welcome back, listeners. We are here with the team from the Seismic Research Center in Trinidad and Dr. Christopher, who is from the Montserrat Volcano Observation in Montserrat. Dr. Beckles, if you don't mind, I'll ask a question. We discussed early on when Dr. Joseph was discussing the whole methodology of testing for the SO2 gas at the Sulphur Springs Park. Talked about low-cost sampler. I think we had some discussion about it. But tell me, is the instrumentation itself, could it be used for other gas research? Could it be expanded upon and further used for other research in other areas?
Certainly, what was developed was a method to collect gases. So by changing the solution in the collection bottles, you can get a variety of different chemicals. As I said, with the hydrogen peroxide solution that we used in this study, we were able to collect sulfur dioxide. But if we changed the solution, we could collect ozone or nitrogen dioxide. So we could actually use it for other things as well.
Okay, so you could expand on the whole use of the instrumentation.
Sure.
Excellent. Dr. Joseph, back to you. In terms of the findings of the projects, what clear recommendations would you have from the findings to the stakeholders, those persons connected with the Sulphur Springs Park or have interest to the park?
As part of the outcomes of the project, one of the things was educational materials that we were able to prepare for use by the stakeholders locally, as well as meaning to provide the information within St. Lucia, as well as to provide it to visitors who may come in and have questions. And we prepared two different types of materials. We prepared brochures that had a summary of the area, as well as the volcanic emissions in general, as well as what can be done to help in terms of protective measures that you can take, simple measures, and such as easy things like if you're susceptible, you think you might be at risk, you put on long sleeve clothing, reduce any kind of strenuous activity, especially in the park area. You can wear a wet handkerchief across your nose, that simple things like that, or you just move away.
Right.
If you move away from the main venting area, if you find that the smells are particularly strong to you. So this is available in a brochure, as well as a poster, which will be exhibited, I believe, at the park, in areas where people and visitors will be able to see them, as well as where the staff themselves can be familiar with the material and can incorporate it in their tours that they do and accompany visitors on. As I mentioned before, one of the other recommendations that we make is and we're hoping that can be done, would be the health impact study of the staff and residents in the area, as well as to pursue the continuous sulfur dioxide monitor to see if that could be something that we can utilize and obtain for use at Sulphur Springs.
Right, excellent. just hearing this, I remember yesterday in our discussions, persons were saying that some people drink the waters at the site actually, and there is a belief that it has some therapeutic value. But in terms of drinking the water, what would you say to that? Is that a practice that you think should be continued?
We did not sample all of the waters of the park. We just sampled at certain sites within the park and rivers inputs that go into the water supply of Sulphur. And well, we did not find any high levels of certain metals that we look for. We didn't look for every single thing. We just looked for certain metals of of concern, such as arsenic and lead and manganese and aluminum and so on. While we did not find any levels of those that were above the WHO 2009 water quality standards, in terms of those in the waters getting into the water supply of Sulphur, what we did find was that in some of the recreational areas used in the park, the Clearwater Pool and the Blackwater Pool, that there were higher levels of aluminum and manganese.
Why would that be so?
But just to finish off, but these weren't found in the natural springs flowing through. So I believe those additional elements, or the heightened levels of those elements, were due to the use of the pools by people, their sunblocks and the deodorants and the chemicals that they have, perfumes, etc., that they use washing off into the pools.
Right.
So while in general I would not recommend drinking of the waters and the pools, for that reason, because we're not quite sure what can be in it at any length of time.
Right.
I mean, I can't enforce. It's just in general. I would not.
Based on your scientific findings, that's just where you're erring on safety here. Excellent. Okay, Dr. Christopher, let me bring you back in here. We've spoken about the Sulphur Springs site, talked about gas emissions. I don't know if but let's go back to what exactly is the Sulphur Springs Park in itself. Let's discuss that in terms of being a natural phenomenon. You hear of it being described as a driving volcano, and you also hear that it may be a dead volcano, and you hear that word volcano. From a volcanologist's scientific overview of the whole system, tell me, what exactly is the phenomenon? And ideally, if there were an eruption to occur, what would be the precursors to that eruption? So let's look at the phenomenon itself.
Okay, first of all, the Sulphur is not the actual volcano. It's just the Sulphur Springs. What it is the surface manifestation of a magma chamber that is somewhere down there that is transferring heat upwards, and the heat interacts with the groundwater, and that forms a sulphur. There's a transfer of heat and probably volatiles as well. That's why we get sulfur dioxide, H2S, and CO2 coming from it. So it's basically a transfer of heat upwards and a surface manifestation of it. So all it tells you is that there is a magma chamber somewhere down there that is quite hot. In terms of a pending eruption, different to the low-cost samplers and the diffusion tubes, I brought down an instrument which is called a multigas. And what that does, it measures carbon dioxide, water, and as well as the two sulfur species, which we were discussing earlier. And basically what I'm looking for is any sort of precursory to an eruption. And in this part of the world, or from these type of volcanoes, I think the general idea is if an eruption were to begin, we would need a fresh pulse of basalt from deep.
That's coming up.
Yeah, coming up from deep. And that basalt, which is a type of magma, would be much hotter and rich in volatiles. And because you expect the volatiles to reach to the surface before the actual magma does, you would expect to see a spike in CO2 and definitely SO2. So those two you would expect to increase relative to the other two species, which is water and H2S. What you would also expect as well is earthquake activity to be on the rise.
You get swarms.
So there will be a number of things which will happen before that magma gets to the surface. So what we're trying to do is to put these baselines in place the seismometers here that SRC are monitoring, the GPS equipment here, which measures ground deformation as well. So there'll be a number of things which will precede that actual eruption, if there's actually an eruption. The point is you can have these things and not have an eruption as well.
Right.
It's not guaranteed. But the idea is to see it coming before it sneaks up on you.
Right. So we are saying that the instrumentation for measuring earthquakes, the swarms, and the machine you just mentioned, the instrumentation, the multi-gas.
Yeah.
Yeah. So this is present. We have that here.
Yeah, well, the multi-gas is not always here. I take it back with me when I leave. But SRC has equipment on island, permanent equipment, seismometers, and GPS equipment that are always collecting data continuously.
Excellent.
And they're being monitored from Trinidad.
Okay. In terms of geothermal energy being dispensed in the activity in the area, does the gravitational pull of the moon have anything to do with that? Is there any correlation between a full moon, to say, and the bubbling and the whole activity there? Is there any correlation at all? I've heard that before, actually.
I'm not quite sure. I don't know much about how the moon would affect volcanism. I know the moon affects the tides, but I'm not quite sure how it would affect volcanism. So
that question did come to us at the Seismic Research Center recently, as one of the things that people were asking. And what we could say is, what the question was posed to us is whether or not it had an effect on the surface activity at Sulphur Springs in terms of increased spouting and bubbling and so on. And our answer was no. That the moon, gravitational pull of the moon, etc., did not have of that kind of influence on the surface activity at Sulphur Springs, and it's not known. As you said, they're daily. There's a daily relationship with tides, but not. Otherwise, you would see it on a daily, you would clearly see waning and fluxing on a daily basis in tandem with the moon, sunrise and sunsets and all of that. But that is not, that's not something that we observe. As I was mentioning, the system is, very dynamic. There are changes.
So it's changing.
Yeah, there are changes beneath the surface of fluid circulating, finding different pathways up. So you can see, one day you might see a pool that may have a lot of water. The next day you might see the water going down, and you might see another pool in its place, coming up with more water. It's just recirculation within the system.
It's a really active system,
occurring.
isn't it?
Yeah.
Right. Phreatic, you have that word, is it phreatic?
Phreatic,
okay,
yeah.
Explosion. There was one here in 1766, am I correct? Could you explain exactly what a phreatic explosion is, and are we susceptible to seeing one in the short term?
Well, okay, let me answer the first question first.
Yeah.
A phreatic explosion is different to a magmatic explosion.
Okay.
A magmatic explosion actually involves magma, whereas a phreatic explosion would be just groundwater being flashed to steam by the hot rocks and generate an explosion. You would get ash from such an explosion, but it would be cold ash.
Okay.
And when you look at the material, you could tell that it's old material and not fresh magmatic material. So I guess that's one of the things that we will be also looking for. If there were to be surface activity, if there was an explosion at Sulphur Springs, let's say, we would collect the ash and have a look at it under a microscope.
Okay.
And if the material was quite fresh, we would see a lot of glass, fresh glass in that material. Yeah, if it was old material, then we would know it was not magmatic. It was just a phreatic, as you said. So a phreatic would be generated from much shallower, and it would be groundwater just being flashed to steam by the hot rocks and generating an explosion.
Okay. I think the next question was in terms of...
I can't say much about timing. I'm not sure how far one away is in the future, but from Sulphur Springs and other soufriers, which is what they are, even though your town is actually called Soufrier.
They actually called Soufrier?
Yeah, they're actually called Soufriers. Yeah.
But knew that. Sure, did you know that?
Yeah, I guess that's why the town was called Soufrier. But it's a French word. But these sort of areas, and whenever you have these hot springs or type scenarios, there's always a possibility of generating a phreatic explosion. And I think there was one in Dominica some time ago.
Right. That's
yeah.
right.
So there is always a possibility of them occurring, but I can't really put.
But there was ashing in at a small event from what we call Gabriel's Crater. I believe sometime in the I don't have the exact date, but within recent times, within the last 20
Gabriel's
years.
Crater?
Yeah, we call it Gabriel's Crater. You know, just a feature,
Just a feature.
in the park that we've given our name
Gabriel's
to.
Crater.
Yes,
Okay.
but it's one of the main events, and the guides are familiar with
Right.
what it is. Sometime within the last 20 years, I can't remember the exact date, we did have ashing from there, that ash venting that reached the main viewing point.
Really?
And that was a very small
Yeah.
event of
Event.
that type.
I see.
Uh-huh.
What caused me to ask the question? I know Japan recently had a phreatic event.
I mean, I think they termed it as a hydrovolcanic, but that was a
Right.
much larger one.
That's
Yes,
that's what caught my
very
attention,
large.
because it was extremely large, and actually there were some hikers. I saw some
Yes,
hikers were
that
caught up
was
there, and I think
caught.
somebody got hurt.
Correct.
So that was the motive for asking the
Yeah.
question.
Well, when I saw the photos and the images first, I thought it was a regular eruption, but
Right.
they obviously had a look at the material
Mhm.
and realized that it was not fresh material. It was old material that was remobilized by this explosion, the shallow
Right.
explosion. So that's why a few days later, they came and said it was not a magmatic event, it was a hydrovolcanic event or a phreatic
Phreatic.
event. I mean, hydrovolcanic is just water
Right.
interacting with the hot material that's there.
Right.
So it wasn't a magmatic push from deep, it was just a shallow process, but it was so large that it actually generated pyroclastic flows.
Understood.
So that was
Understood.
I don't think I've ever seen a phreatic explosion generate
That was
pyroclastic
really
flows
a
before.
unique event.
Yeah,
in
it was a
itself.
fairly large one.
Good. Dr. Beckles, let me ask. We discussed SO2 a while ago, but in terms of other gas, I know there are other gases being emitted at the site or generally from volcanoes. I know we talked about the sulfur dioxide, but what other gases, and in terms of the hazards specific to them, what they could probably do in high concentration? Could we just look at that again, if you don't mind?
Okay. Well, I think for the most part, the only other gas I would probably you would see in any quantity would be hydrogen sulfide. That was the H2S that Dr. Christopher mentioned
Is that the
earlier.
egg rotten
That's
egg
the
smell?
rotten egg smell
That's
one.
the gas.
Yes, which it is actually a toxic gas. However, humans are very, very sensitive to it, so that you will detect it at exceedingly low levels. I mean, you can smell it in the part per billion ranges, so very, very small quantities, and we can detect it.
Yeah.
It's one of the few gases we are on par with a dog with. So when we smell it, it's not a easy. You can't detect the concentration that you're smelling may or may not be. You can't use your nose as a detector, and of course it will move around. Winds will blow, so. It's the same, I think, pretty much kind of precautions you'd have to deal with the sulfur dioxide, the same kind of situations.
Right.
You know, if you detect particularly high levels, then it's to move away. There are ways to detect it. You can, you know, apart from the large instruments, there are little badges that you can wear that will pick up if the levels are over a certain amount, and you can, you know, take necessary action.
We spoke of asphyxiant gases yesterday. What exactly are those?
Those would be gases like carbon dioxide, which exclude oxygen. So they don't themselves necessarily cause thing, but they exclude oxygen.
Right.
Then, in addition, there's carbon monoxide, which is an active asphyxiant, in which case it's not just that it excludes oxygen, but it actually reacts with your blood, and so prevents the blood from carrying oxygen, with the same end result in that you cannot carry oxygen to your tissues. And
Understood. And okay, listeners, I know everybody's listening attentively, and I believe the team is so thorough that they don't have many questions. We'll take our final break, and when we come back, we'll ask two other questions, and we'll wrap up with the team. And a very warm welcome back to our listeners. Again, with us this morning, we have a team from the Seismic Research Center in the University of the West Indies, and Dr. Christopher, who is from the Montserrat Volcano Observatory in Montserrat. Dr. Christopher, to you. in terms of your experience in Montserrat, I know you've gone through the experience of the volcano erupting over the past couple of years, and I know there's been a lot of mix of emotions. But my question is from an emotional standpoint and a scientific standpoint. Could you give me your general views and your experience?
Well, the thing is, I actually was evacuated.
You were evacuated?
Yeah, my home is actually destroyed, but where I was living. So I guess as someone who had to move, it was unbelievable at first because for most people who don't know, this volcano has been going for about 18 years. It started in 95, and I mean, when it started, most people didn't even know there was a volcano in Montserrat.
Right.
And so over the first few months, we were a bit oblivious as to what to expect. I was still in school at the time, so in my opinion, this would be over in 5 months.
Right.
But it just kept going on and ramping up. And then we had to leave Plymouth area and head to the north. So over time, I kind of made my peace with it, and because I was really interested in this sort of stuff, I pursued it. But it's not easy to see some place that you grew up in no longer exist. It's not a good experience. But I think most people in the country now are cool with it. But it's not a good experience, and I think eventually you get used to it and move on with your life.
Right.
And the thing about these sorts of disasters, if you want to call them that, or phenomena, is we can't stop them.
Yeah.
All we can do is mitigate them and try and avoid casualties from them. So, and I think we've done a fairly good job in Montserrat so far in terms of minimizing casualties from that volcano.
Excellent. In terms of volcanic activity, what is the state of the volcano at the moment?
There hasn't been any fresh magma at the surface since February 2010. But currently we're pumping out a lot of gas, a lot of SO2 from that volcano. And simply because the volcano is erupting or active, if you like, there's a lot more SO2 than you get here. We get like hundreds of tons of SO2 per day on average.
Tons?
Yeah, tons, because that's how we measure it in tons. I'm more, worried about the quantity or the mass of SO2 coming out of it rather than just the concentration. And that is what we're trying to quantify, how much magma is actually degassing based on how much sulfur we're seeing. So because the system is hotter, then as I was mentioning earlier, the ratio of SO2 to H2S would have switched. Right. And that's one of the things you would expect to see. So in our case, H2S is down, hydrogen sulfide is down, and sulfur dioxide is up.
Right.
In your case, it would be reversed.
Right.
You'll get a bit more hydrogen sulfide here than SO2. So we're still getting quite a lot of SO2 coming out. Not as much as before, but it's still enough to be a problem because some active volcanoes, let's say a volcano like Merapi, which is in Indonesia,
right.
I mean, when it's going on all full cylinders, it pumps out around 200, 300 tons per day. Our long-term average is around 500 tons per day.
Right.
So it's a fairly sulfur-rich volcano.
Right.
There are still earthquakes, which we call volcano tectonic events.
Right.
And I think we equate them to movement of magma within the shallow parts of the system. And there's still deformation as well.
Right.
And so these are the three areas that we use to monitor the volcano. Deformation, degassing, and seismics, which are the earthquakes.
Yes.
And so those three things are still going.
Right.
So even though there's no activity at the surface, it would be irresponsible to say that the eruption has stopped. Because what we don't know if it's actually in the process of dying or if it's just resting to come back at us again.
Are there any studies that show any teleconnections between activity in the other islands in terms of the volcanic activity?
Yeah, this is a common question. Volcanoes tend to mind their own business, and they're not interconnected. The reservoirs which feed these volcanoes are fairly shallow, and where the volcanoes are located at the surface has to do with the weaknesses in the crust. So the actual reservoir could be offset laterally to the east, west, north, or south, and not necessarily straight down. So where they are at the surface doesn't give you an indication of where the reservoirs are, even though they might be close together on the surface.
I see. Dr. Joseph, St. Lucia's looking at alternative energy, and geothermal energy is what's being discussed. That involves drilling. Should we be concerned that drilling may cause an increase in the gas, or the gassing, as you would say, emissions at the site? and could in any way the seismic activity, the actual shakings and rumblings of the drills cause some magmatic activity. Am I right to say that? Some magmatic activities at all? Could that occur?
In generally, it's not seen that geothermal exploration at geothermal sites interfere with the magmatic system because the drilling occurs at shallower depths. It doesn't tap into the reservoir. I mean, I know that in Iceland, that has happened, but it's a different type of system we're dealing with. With our andesitic volcanoes, and so I don't expect that the exploration of geothermal energy at Sulphur Springs can cause a magmatic eruption. As I explained, the system is dynamic and there can be changes in the emissions at the surface, but this is something that will have to be monitored by the people utilizing the resources. But more importantly, in terms of they would have to measure the emissions that they themselves produce when they extract the fluids, use it for the heat source, and then re-inject it into but there is a certain amount of emissions that these plants themselves emit, and that's part of the emissions monitoring that would have to be done, as well as the general ambient air quality.
All right, here's the big question that is on everybody's minds, and I think we want to ask, if anything else. In 1997, we experienced, I think, a 7.4 magnitude earthquake. I can't remember the depth, but it kind of really shook St. Lucians, because we hadn't experienced an event like that in a number of years. And more sadly is the 2010 event in Haiti, which is 5 years now. It's basically fresh in everybody's minds. Recently, I read a report from the SRC, the Seismic Research Center, which was kind of advocating for governments to legislate and ensure that their building codes are in check, because there is an indication that obviously we are overdue for 8.0 plus magnitude earthquake, which I think the study said, the report was that it's 32 times more energy being released. Let me ask a question. I know we cannot kind of predict those events, but in terms of the whole history and data that we have, give me a learned perspective from where we are standing in terms of what to expect over the next years, or it's more so as a matter of preparedness from our end.
Okay, let me just say that the East Caribbean is in a very different regime to the Greater Antilles. So Haiti, Jamaica, Cuba, Santo Domingo, Puerto Rico, that is a strike-slip boundary that they've got to deal with there. And the thing about strike-slip boundaries, the earthquakes tend to be a bit shallower. Okay. And a shallow earthquake, and a shallower earthquake would cause more problems than a deeper one. Okay. I'm sure you've heard stories about Port Royal. Mm-hmm. Yes, so that part of the Caribbean is no stranger to large events. In terms of the subduction zone regime, which we are in the East Caribbean, I think what that report is saying that basically the plates are always moving. And ideally, you would want to have a large number of small events. But the longer in between events is the more likely that you'll get a larger one, because the stress is always building up continuously. I mean, as you said, we can't put a finger on actually when it may or may not happen. But I think the general idea is the longer in between events is the more likely for it to be bigger. Mm-hmm. And that's the general idea.
All right. In terms of the same question, tsunamis. I know after the Japan event, everybody was very hyped about tsunamis. And is the Caribbean very susceptible for tsunamis? I mean, in terms of what happens in terms of the earthquakes that we've had over the past couple of years, is it something that can happen more so, or are we out of the woods?
It can happen, but I wouldn't use the word very to describe it, because I think one of the good things in the Caribbean, which is different to places like Indonesia and Japan, the subduction rate is quite slow. So we get less eruptions, less earthquakes. You know, I mean, you always hear about earthquakes and eruptions in Japan and tsunamis in that part of the world. And we're in a similar regime to them, but things here are happening much slower than it is for them. So I think in one way that's a good thing because we get less geohazards. But I think it might be problematic in terms of people being aware of what the situation we are in. Because the less these things happen, then people will not just be aware of there's a potential for them to happen. You know, so I was quite pleased when I was here last year to see that there was actually a tsunami drill happening in Sulphur, because I think people need to be aware of what they need to do if there is a earthquake or a tsunami. I mean, everyone's familiar with hurricanes because we get them every year. You know, so because of the frequency of them, you know, we're quite comfortable with dealing with them. But through the earthquakes and tsunamis and eruptions are not really that frequent, then we need to raise awareness and make people not necessarily be comfortable, but know what to do when there is one, and you will definitely save more lives that way.
That's right, that's right. Well, we've kind of come to the end of our very informative session. Dr. Joseph, any final words from you?
I just want to thank the local stakeholders, the Sulphur Regional Development Foundation, as well as NEMO, for collaborating with us, as well as the support from the staff at Sulphur Springs and the Sir Arthur Lewis Community College, as well as the Sulphur Comprehensive Secondary School, for being a part of the project. They were the ones, you know, doing the actual measurements and so on while we weren't here. And without their support and commitment to the project, we would not have gotten things off the ground and been able to provide the data that we can now share with everyone.
Excellent. Dr. Beckles.
Well, I guess I'd like to support Dr. Joseph's sentiments. Again, the low-cost sampler was a kind of an idea, a little brain idea of my own, and it was really wonderful to have everyone's help so that it could actually come out on the ground, you know, out of my brain and onto the road, so to speak. Yes. So, and I hope that the persons who, at least at the schools, they had information, so hopefully they can use them, if only for their own students, you know, to expose them to doing a little science out in the field. That would be fine. And we can see what we can do to maybe make that more, you know, spread it out a little further.
So I think we kind of had a discussion about it being a business idea. Are we looking to kind of patent that? I think I want to put a picture in myself.
No. As I said at the meeting yesterday, it's you know, educational use only.
Fine, we're fine with that. Dr. Christopher.
Yeah, it's always a pleasure to be here. I really love St. Lucia, and this is a very nice town that we've got here.
I can see the passion.
Yeah, the people are quite friendly here, you know, and I feel really welcome, and I appreciate that a lot, you know, and I look forward to working here in the future because it's a lovely place.
Yes, it is.
And I'm looking to get a passport and stay.
That's fine, that's fine. You're always welcome.
Okay, no
problem. Well, yeah. Well, I mean, for me, from my personal experience, I mean, it's wonderful to hear from you guys. You know, I think you answered a lot of questions and debunked a lot of myths. So your efforts obviously will echo quite a lot. Probably send a letter to UWI, make sure you'll get an award or something for that work. Again, I guess we have to kind of put something there. Thank you so very much for coming in this morning. We really appreciate your efforts. We appreciate your time and the work done. And so on behalf of the management of staff of 88.5 Sulphur FM, we again thank you. And again, just want to wish you guys a wonderful trip back home, and hope we could do this again some other time. You know.
Yes, thank you.
Thank you.
Excellent.